How you doing today, guys? Welcome back to another day of 7th grade math. This is Mr. Gomez, your favorite teacher in the whole world. And today, we're going to start talking about scale factors. Before I start, please subscribe, turn the notification bell on, and let's ride. Alright, let me ask you something.
Yes, sir.
What's this?
Your pinky. Bigger.
What?
Bigger. Like bigger. Like,
What do you mean?
Like wider. Like
Increase.
decrease. Increasing.
Increase, okay.
Decrease.
Okay. When do you use this?
On the computer.
On the computer? How?
When you take pictures, like you can either like make it small.
Zoom in.
Zoom in.
Yeah, zoom
Very
in.
good.
So like
Zoom in.
Zoom out.
Zoom out.
Theodore said that.
Okay. So let me ask you. When you do this, if you're looking at a picture of your crush right there,
How
boom.
much ring pops?
Eyes too small and you actually want to look at your crush, right?
Describe it to Mister.
Okay. You go like this. Why would you go like this?
Because I want to see your face.
Scope is not a news, but why would you go like
Because
this?
you want to see your face.
Because I know you guys do that, right?
Yeah.
Whatever. Okay.
I mean,
You go like this. What are you trying to do?
like zoom in on her face.
Zoom in on her face,
And
right?
maybe kiss it.
Okay. Some of you do that. That's fine. Okay. When you go like this, that's your crush, right? You know her. You know him. Okay. It's a picture from today. Let's say you go like this. What happened to the picture?
It zooms out.
It zoom in, right? It got what?
Bigger.
Bigger. Did your crush get fatter or skinnier when you did this? Did they? Did they?
No, it's just like the picture. It zoomed in, so it's got like fatter, like it's like this, right? It's like this.
Zoom in into the part where you're zooming in.
It's zooming into the part that you were trying to look at, right? So hopefully you're looking at their faces, right? Nothing else. You're looking at their eyes. You want to look at the color of the eyes, but did the eyes actually get bigger or smaller?
Bigger.
It got bigger, but did they get fatter?
Yeah.
What shape is the iris of your eye?
Circle.
Circle. When you zoom in, does it become an oval? Does it become an oval? No. It stays a circle. So now let me touch the screen. Let's look at this shape right here.
Oh, that's your crush.
Boom.
Oh no.
Okay? Now, wait. What happened? Did he get fatter?
No.
No. It looks the same,
Yeah.
but you can see it better, right? If I zoom out, did he get skinnier?
It's like Carlos.
Skinnier? Skinnier? No, he just got farther away, right? So if I walk out from the camera or from you, I might appear that I'm shorter than I actually am, but I'm actually the same proportion. Okay? What happened to the picture is it is proportionally getting bigger or getting smaller.
Bigger.
That's what proportionality is. That's what scale factors is. Okay? That's what we're going to be talking about today. So now that we get the picture, let me show you something else. And I'm going to turn off my camera.
House is right.
Okay, wait. Let's not talk about your house. I want you to look at on the bottom. What is this? A map. Okay? Before Google Maps, Apple Maps, Garmin, whatever, we have
An actual map.
an atlas, right? Truck drivers still use that to this day. A lot of people use that. And I want you to look at something at the bottom right corner of this map. Don't look at the clock. At the bottom right here. Under the person. I know you can. I can't zoom in on this one because if I zoom in, it'll zoom in the map. But there's a little legend right there.
2 miles.
That's a number. Is that what?
2 miles.
2 miles. Okay, let me turn on the camera. Maybe because hold on. All right. Hopefully you can see me right here. Over here, we have a number 2 miles, and we have a little length right here that you can actually get a ruler and measure. What does it mean? And I'm gonna try to do it with my fingers and not move the fingers. Freak, my picture is right here. I'm right here on top of that. But right there. So 2 miles right here. I'm gonna take them and Put them over here. Right there. Look at this map. That's Beltway 8. That's around where AMC is at. And 2 miles right here. That's probably about where Ashbrook is at.
Yes, sir.
Is that approximately 2 miles?
Yes, sir.
Yes.
Wait. AMC's on the dome, right?
Right here.
And
Ashbrook right there. That's about 2 miles.
I live exactly by AMC.
Okay?
That's fine.
So now, let me look at something. You know I gotta edit that, right? Okay. That's a 2 miles right there. Boom. Put it right there. Now look at what happened. Look at what's gonna happen when I zoom in. When I zoom in on this map, and just wait for a little bit. Let's go to where we are. Where are we? Right here. Okay, what happened over here?
It went to 1 mile.
It went to 1 mile, and look at the length. It changed a little bit too, but you can actually get a ruler and put it over here. So let's say let's see, if I'm at Fuquay and 45, put over here, between Fuquay and Shaver is almost a mile. It's a little over a mile, according to my scale factor right here. This is the scale factor. Between Fuquay and Shaver, Sam's and Almira Mall, it's a little over a mile, right? So when I zoom out, let's look at what happened when I'm gonna zoom out. And just wait for it. So now it's not longer gonna be 1 mile.
Why is San Antonio so far? God dang, mister.
Language recording.
I heard you.
I said dang. I'm gonna call you home. I said
Mon
dang.
thing.
That's mine.
He said no. That's not mine. No.
My address is Austin.
Mon.
Whenever I said
We got
Waiting for this.
Everybody know we get screwed.
Come on, thing.
that's why
Whoa.
you can't buy anything with that. Where's your money?
There you go. Oh, kilometers. No, I don't want kilometers.
I thought that was
20. Okay, now, look at my factor now. What is this number?
20 miles.
20 miles represented by this distance, which if I put my ruler, it'll be a little, like, all the way up to here on my pen. Right here. So let's say from Houston to San Antonio, how many of those can you fit from downtown Houston? That's 1, 2, 3, 4, 5, 6, 7, 8, about 9. What is 9 times 20?
According to my calculations, 180.
180. So the distance between Houston and San Antonio is gonna be approximately 180 miles, which it is.
Bro?
Yeah.
How in hours? How long will it take?
It'll be about 3 hours,
Oh,
depending on the unit rate. What you're driving? If you're driving 60 miles per hour, it'll take you 3 hours. But if you go faster, it'll take you less time.
what if I drive my moto over there?
All right. So we get the idea of zoom in, zoom out.
Yes, sir.
All right. All right. So let's see. We're looking at these pictures, and I want to give you a minute, and I want you to write down in the comments. You guys write in your paper. What do you notice? Okay, this is the original, the big one on the top left. And you're looking at portraits A through E. What do you notice? What do you wonder? You just go ahead and write it down. Whatever you notice, whatever you wonder. Just go ahead and write it down. I'm going to give you a minute. You guys watching the video, go ahead and write it in the comments. What do you notice? What do you wonder? On your paper. You notice, you wonder. All right, so let's go ahead and raise in your hand. What do you notice? Oscar.
I noticed that in the B, he got like wider, like someone like pushed his thing out. And
Okay.
And the E6, it's like vertical instead of straight. It like changed like this.
You twisted.
Yeah.
Okay. Anybody else? Raise your hand.
Twisted like.
Notice. Anybody else? Let's see. Omar.
C got smaller.
C got smaller. Okay. Yes, Fabian?
A, he got skinnier.
A got skinnier. Okay. Anybody? Gabriel? E is slanted. That's another good word. Good vocabulary word instead of inclined. Slanted. Very good. Yes, sir?
B, he got, like, it looks like he got chubbier, but they just widened out the picture.
Okay, Chauvier. That's the good thing that we noticed that. Now, wonders. What do you wonder? Raise your hand. Somebody else. Major. What do you wonder? Anybody else? Raise your hand. What do you wonder? What do you want? What do y'all wonder?
Oh, where?
Yes.
I wonder, like, how, like how we have the technology to do that.
Okay.
Like, how does it get, I don't know how to explain this.
That's okay. Anybody else wonders? Okay, that's fine. Let's keep on going. I hear some good things right here. Now, let me ask you. Looking at the original, just the portrait, okay? The shape of the portrait, not the person. What shape is it? Rectangle.
Rectangle.
Okay? Now, let's look at A. Is A rectangle? Yes. Now, B. Look at the numbers, though. Look at the numbers on B. What are the numbers on B? 4 and 4. So that means that this other side is also 4 and the bottom is? And if it has the same size, it's actually a square. Is the square the same as a rectangle?
No.
Nope.
The rectangle is longer and the square is like shorter.
Okay. So the square is not a rectangle. Now, you mentioned something about the slanted one. Which one is the slanted one?
E6.
E. Is it a rectangle?
Nope.
No.
Yes. No.
Wait.
It's flat and it's flat.
But the rectangle has to have opposite sides parallel to each other, right? Well, this one is too. But how many sides does E have?
A 4.
4. But it's not a rectangle, right? Because they're not
Like they're not like all like.
the angles. They're not 90 degrees. Remember?
Yeah.
On rectangles, the angles, the inside angles, all of the corners have to be 90 degrees. Is that the case on E? No. Right? They're slanted. So one of them is more than 90. 2 of them are more than 90 and 2 of them are less than 90. But it's 4 sides, which is called starts with a P. It's a long word.
Parallelogram.
What is it? Parallelogram. Is a parallelogram a rectangle? Not always. So this is not the same. It's not the same shape. Now, on similar figures and scale factors, just like we zoom in, the shape has to be the same. In order for it to be similar, the shape has to be the same. It has to be proportional. Like when we're talking about the zooming into the eyes of your crush, right? The eye doesn't get oval, it's still round. It doesn't change the shape, right? So if we look at this one right here, the original and A, just look at the eyes. Circle, oval. It got taller or skinnier. It shouldn't change. It should be the same. So is A similar? No, it is a rectangle, but it's not similar. So that leaves us with with C and D. Let's look at D for a second. Which one do you think are scale copies? We already ruled out 3 of them.
4.
What about C?
It's small.
It's smaller. Does it change the appearance of that person?
Nope.
It looks almost the same, but it just got shrinked, right? So I think C might be we need more information, but I can call this maybe yes. Now, if we have numbers, we can actually do math and figure that out. We can actually do math and figure that out. Let's see. We gotta find keyword corresponding side. Okay? So if I look at the original, what's on top of the hair? What number is that? 12.
So it's 12 on the top
12 goes with what number on letter D? With 4. So, what about 18
18 going on the side.
goes on the side, right? So now let me ask you something. Whenever we're talking about scale factors and similar figures, things like this subject, we are only going to multiply or divide. We're not adding or subtracting, okay? It's a scale factor where it's proportionality, it's fractions. We're going to multiply or divide. Look at 4 and look at 12. What happened between them? Why can I multiply 4 by to get 12 or divide 12 by to get
3.
by 3, right? So this changed by a factor of 3. So if you multiply 4 times 3, you get 12. But if you multiply one of them by 3, you have to multiply the other one as well. Just like equations. What you do to one side, you do to the other.
6 times 7.
So, very good. If you multiply this times 3, what do you get?
18.
Is this 18?
Yes.
Yes. That's exactly what we're looking for.
So technically,
With math, D for fact is one of them. And C, I'm going to say yes, although we don't have any numbers, but it looks very proportional. So I can say and also C. If we had numbers, then we can do the math and establish that. All right. Any questions so far?
No.
All right. So let's look at this. Scale factor. We have a formula. New divided by original. A fraction line represents a proportion, a ratio. Okay. New divided by the original. This formula is not going to be provided to you. So we're going to look back at portrait D. Portrait D. And we're going to pick one of the sides and compare it to the original. I will pick the smaller number. Let's look at portrait D. And what is the smaller number? 4 or 6? 4. So the new one is going to be 4. And the original, the corresponding side to 4 is what? 12. Do I have a fraction now? Yes, that's a ratio, a proportion. Can I simplify this proportion? Yes, by what?
1/3.
But by what can we divide it to get that? We got to divide them by what to simplify it? Can we divide them by 2? Yes, we can. That will give us 2 6. But can we go higher than that? Can we divide them both of them by 3? The 12, yes, but not the 4. Can we divide both of them by 4? Yeah.
3.
So 4 divided by 4 gives you 1. And 12 divided by 4 gives you 3. So the scale factor is the proportion of 1/3. You can also write this in 2 more different ways. You can also write 1 dot dot 3 or 1 2 3. Whatever the first number is, that's the new one. The second number is the original. So that means it went from big to small. If the first number was bigger one, that means it went from small to big. Okay? Any questions so far? I hope that you learned something today. If you did, give it a thumbs up. I'm going to make this a 2-part video and we're going to go over the next pages. So stay tuned for that. Make sure you subscribe, turn the notification bell on. And other than that, let's ride.
Let's ride. Let's ride. Let's ride.